Double-rotted differential leveling is a method of determining the difference in elevation between points by employing two routes simultaneously. Two turning points are established such that at each setup of the leveling instrument, two sets of independent back sights and foresights are taken. Employing double-rotted differential leveling provides a continuous check on the process of determining ground elevations while the work is in progress. The method is also useful when there is an urgent need to undertake differential leveling in a short period of time, where no established benchmarks are available for checking results. The objective of this fieldwork exercise is to 1. Acquire and develop the skills of determining the vertical distance of a remote point by applying trigonometric and related analysis, and 2. To develop the skills of reading vertical angles using theodolite or total station. The instruments and accessories used in this fieldwork exercise are the following: theodolite, leveling rod, markers, measuring tape, plumb bob, and range pole.
Set up the theodolite at a convenient location and call it point A, where the leveling rod and the remote point are visible. Using the telescope, take sight at the topmost remote point and then read the vertical angle and record it as alpha on Table 5 Trigonometric Leveling. Take another sight for the second trial. This is done to determine the precision of the observations. Calculate the mean of the two vertical angles or the angle of elevation of the specified point from the first station. Set the leveling staff or rod vertically near the base of the remote point and take the level foresight on the rod to determine the height of the instrument. Transfer the instrument level or the theodolite towards the location of the remote point and designate it as Station B. Measure its distance by taping from the initial point, Station A. Record this as distance AB. After centering the bubble of the instrument level, sight at the same topmost remote point twice using the telescope and record as beta on Table 5 Trigonometric Leveling. After recording these two observations of vertical angle, calculate the mean. Level the telescope while at B and get the height of the instrument by sighting the same leveling rod near the base of the remote point. Analyze the figure below. The right triangles form to determine the height of the remote point. This fieldwork will not consider the effects of combined correction of Earth's curvature and refraction. For the analysis, determine the difference in elevation between two instrument setups given by the equation difference in height is equal to h sub 1 minus h sub 2. Consider the triangle B'EF, then solve for distance x using the tangent function. Tangent beta is equal to h sub 1 minus h sub 2 over x. Determine the sum of distance AB and distance x for the analysis of triangle A'FD. A'F is equal to AB plus x. Consider triangle A'FD and use sine law to determine the distance FD given by the equation AB plus x over sine beta minus alpha is equal to FD over sine alpha. Lastly, consider triangle FDG and determine the height of the remote point DG given by the equation sine beta is equal to height minus h sub 1 over FD.